You're in a great spot now to understand how rechargeable lithium-ion batteries work in Chapter 3. We'll focus less on chemicals and more on principles in our description of this technology. You'll find you've learned many of the principles in Chapters 1 and 2. A rechargeable lithium-ion battery with this form factor will look like its non-rechargeable primary counterparts. The difference is mostly what's inside. They're engineered and their materials and chemicals are selected so that the redox reactions involved are reversible. The original chemical conditions within the electrochemical cell can be restored over and over by recharging from an external source. This makes rechargeable lithium-ion batteries significantly more expensive than their primary battery counterparts. Each battery, again with this form factor, will be physically protected by a metal jacket with a plastic wrap over the top. You should know this end of the battery is the positive terminal, and the positive terminal is called the cathode. The flat end of the battery is the negative terminal, and you should know by now to call it the anode. Now for our standard disclaimer. Our illustrations and descriptions have been simplified to provide a conceptual understanding of how a lithium-ion battery works. This illustration accurately reflects the interior geography of a lithium-ion battery. Our model battery blueprint looks like this, so you may more easily visualize and understand rechargeable lithium-ion battery concepts. Now, let's get started. Connected in a circuit, electrons from a lithium-ion battery will, as is true in all batteries, flow from the anode to the cathode as you see here. That flow of electrons, as you know, provides direct current electricity which is capable of powering an appropriate load. The anode material in a lithium-ion battery is often graphite, carbon, that contains lithium atoms inserted between layers in the graphite. In this state, the anode has the chemical formula LiC6. Connected in the circuit you see, electrons will be lost by the lithium atoms inserted in the graphite. The lithium atoms are oxidized to produce lithium ions, Li+1. The lithium ions leave the spaces between the layers of graphite and enter the electrolyte. Oxidation, the loss of electrons, happens at the anode, the negative battery terminal. In this type of lithium-ion battery, the cathode material is cobalt oxide, CoO2. Connected in the circuit you see, lithium ions in the electrolyte will move into the cobalt oxide, filling empty spaces between layers of the cobalt oxide crystal network. For each lithium ion that reacts in this way, one electron will be gained by the cobalt oxide. The cobalt oxide is reduced and its chemical formula is transformed to lithium cobalt oxide, LiCoO2. Reduction, the gaining of electrons, happens at the cathode, the positive battery terminal. As you've been taught, every battery must have a well-chosen electrolyte. The electrolyte provides two important functions. One, it allows for the movement of ions through the electrolyte. And two, it prevents the transfer of electrons through it. In a lithium-ion rechargeable, the electrolyte is frequently composed of the chemical salt lithium hexafluorophosphate, LiPF6, dissolved in an organic solvent. When dissolved, LiPF6 yields Li+1 lithium ions and Pf6-1 ions. This makes it easy for lithium ions to move through the electrolyte. Electrons, however, cannot pass through the electrolyte. To move from the anode to the cathode or back during recharging, electrons must use a wired electrical circuit for their path. As you know, most commercial batteries use a separator to prevent internal short circuits between the electrodes. This physical barrier prevents the possibility of contact between anode and cathode materials by physically separating them. However, it also allows for the movement of ions through the electrolyte, permitting the battery to produce electricity. A thin sheet of porous plastic material called polyolefin is the separator for most lithium-ion batteries. Importantly, what is the voltage for a lithium-ion rechargeable battery? As always, this is determined primarily by the natural electrical potential difference between anode and cathode materials and is usually between 3 and 4 volts. To recharge a lithium-ion battery, the electrons and ions have to be forced in the opposite direction from battery discharge. To do this, a potential that's larger than the battery's inherent potential of 3 to 4 volts, but opposite in polarity, must be applied. The electricity grid provides us with 120 volts, which is much too high. The grid also provides alternating current, or AC electricity, and the battery needs direct current. So a battery recharger does several things. It changes AC electricity to DC. Then it steps the voltage down to about 5 volts. 5 volts is enough to overcome the natural electrical potential of 3 to 4 volts between anode and cathode materials, and that moves the electrons in the direction opposite of their natural tendency. Overcharging can cause physical damage and harmful side reactions to occur at the graphite anode, and over-discharging can cause physical damage and harmful side reactions to occur at the cobalt oxide cathode. For these reasons, almost every kind of lithium-ion rechargeable battery includes some type of battery management system to limit both charging and discharging to within a safe range. This protects the health of the battery materials and promotes longer battery life. Surely you've noticed that your cell phone gets warm when it's charging. In larger batteries, the amount of heat released can be quite large. That's why many larger lithium-ion battery applications also employ a thermal management system to measure and maintain a stable battery operating temperature. Let's recap. What are the desirable properties for all lithium-ion rechargeables? They must provide for reliable, powerful discharge. They must allow for reversible oxidation and reduction reactions. The reversible reactions must be repeatable for hundreds or thousands of charge and discharge cycles without excessive loss of performance. They need to be chemically stable when not in use. Ideally, they are small and lightweight, especially for mobile applications. They need to be relatively safe to handle in production and price competitive to produce. The anode material? It must be electrically conductive and have a chemical tendency to lose electrons. And it must readily accept electrons back from the cathode when energy is applied to recharge the battery. The cathode material? It must be electrically conductive and have a chemical tendency to gain electrons. And it must return the electrons to the anode when energy is applied to recharge the battery. And the electrolyte? It needs to allow for the movement of chemical ions through it. It must prevent the movement of electrons through it. And it must be unreactive with anode and cathode materials. And finally, the separator. It must be chemically unreactive, porous to allow chemical ions to pass through it, and ideally is thin but strong. Before we finish, let's talk about lithium-ion rechargeable battery technologies more generally. In this video, we've introduced you to lithium-ion technology by featuring one of 6 general types of lithium-ion rechargeables. If you understand how that particular technology, lithium cobalt oxide, LiCO, O2, or LCO technology works, you'll understand the principles behind the other lithium-ion technologies as well. Here you see a listing of all 6 kinds of lithium-ion renewable battery types. Each has somewhat different materials, design, and chemistry. For this reason, each kind has its own advantages, disadvantages, and applications. This means those who make products powered by rechargeables have different choices available from which to make their preferred or best battery choice for use in their products. This list may also be found in your student lesson. Furthermore, in this video series, we've only looked at a handful of common battery types. There are many other battery chemistries in existence. Here is a partial list that may also be found in your student lesson. You should understand that renewable battery technologies, lithium-ion and otherwise, is an area of continuous and rich research, helping to push innovation of many kinds along in the American economy. Now for a final thought before signing off. Check the classwork assigned to you to complete while watching this video. Double-check it to make sure it's finished and well done. Complete the after you view the video classwork, then submit for grading on time. This advice has been offered free of charge.